Hi, good morning, class. So I'm making a video going over some concepts from chapter 4 and 5 that you'd asked me to discuss. I picked out a number of them from chapter 4 and 5. Many of you had some similar issues, so hopefully this will help you as you prepare for midterm 2 next week. So in chapter 4, the first thing that some people had asked about is how to identify when something's a dependent or independent equations and so forth. So I thought it would be helpful just to go through the different scenarios. So when we have a oops, where's my cursor go? There we go. All right, so when I have a system of equations with two variables, we have three different possibilities, right? So we can have one solution, right? Or I can have no solution, or we can have a situation where there are infinite solutions. Right? And recall that the one solution, no solution, or infinite solutions, these are referring to the number of solutions, right? Not actually the solution. So when we have a scenario with one solution, right, this happens when my two lines are intersecting, right, at one point, right? So maybe something like this. So this point here is my one solution in the form xy, right? In the case where we have no solution, what that looks like graphically are two parallel lines. Right. So in other words, line L1 is parallel to L2, right? And then infinite solutions is when both equations are graphed on top of each other, right? So here's the blue, then the green is literally right on top, right? So every point matches. Right. So then we can talk about the different characteristics with each spot, right? So when we know how to recognize when something is just one solution, we're going to have different slopes, right? When something has no solution, right, two parallel lines, what we're going to find is that we have different slopes. But we also have to have different y-intercepts. Or excuse me, this should be the same same slope. Got ahead of myself, right? So we have the same slope and different y-intercepts, right? And when two lines are parallel, right, that means they have the same slope. So then when something has infinite solution, then this is going to have the same slope and the same y-intercept, right? The same b value, right? So when we look at their lines, right, it's helpful to take the system and put them both in slope-intercept form, and then you can easily tell like what is this one solution, no solution, or infinite solutions, right? So then now we need to discuss the dependent, independent equations, consistent, inconsistent system. So Dependent, right? This is basically referring to having the same line, right? The same equation, right? Where independent are different lines. So when I graph them, they have different solutions. Consistent means you have at least one solution. And inconsistent, that would be no solution. Right, so these are just terms that we use. And not only just for two variables, we can extend this beyond two variables. We could also use these terms when we have nonlinear systems, which we won't cover in this class, right? So these are just some general terms. So in the case where we have one solution, right, these two equations would be independent, right, because they're not the same equation. So I have independent equations. And I would say that this is a consistent system, right? Because I have at least one solution, right? So notice that we're only using one or the other, right? So we say dependent or independent, or consistent or inconsistent, right? So we can pick one of these terms from each row here to describe the system. So in number 2, where we have no solution, these would be independent equations still. Oops. Right. But we would have an inconsistent system. Right? Because we don't have a solution here, right? So then lastly, with the third scenario, we have infinite solutions. This would be an example of dependent equations, right? Because the lines are the same. I can't, getting ahead of myself every time I try to spell that. Independent equations. And this would be a consistent system. Right? Good. So those are those 3 scenarios. Pull this down a little bit. Right? So I wanted to give a system and walk through like how to tell the number of solutions without solving it, right? So let me pull one out of the book here. All right. So we could do something like 3x plus y equals negative 14, and 4x plus 3y equals negative 22. Right? So if this is my system of equations, again, the way to tell what category they fit in is we need to use what's in black, right? And it looks like I accidentally erased this. Right, different b values. Right, so we need to first look at their slopes, right? Are they different slopes or are they the same slope? And if it's so if we have different slopes, right, that's one solution. If we have the same slopes, then it's either going to be no solution or infinite solutions. And then if the slope is the same, then we have to look at their y-intercept, right, to determine if it's no solution or infinite solution. So the easiest way to do this is to take these 2 equations and put them in slope-intercept form, right? Y equals mx plus b, right? So then I can identify m and I can identify b. So I'll start with the first one, 3x plus y equals minus 14, right? So I can just subtract 3x from both sides. I get y equals minus 3x minus 14, right? So there's the first equation in slope-intercept form. The next one is 4x plus 3y equals negative 22, right? So I need to subtract 4x from both sides. That gives me 3y equals minus 4x minus 22. And then now divide both sides by 3. So I'm left with y equals negative 4 thirds x minus 22 thirds. Right? So again, the first thing I want to look at is their slope, right? So the slope here is negative 3. And the slope for the second equation is negative 4 thirds. And hopefully, you realize that negative 3 is not equal to negative 4 thirds. So that is this scenario here, right? Where we have different slopes. So we have one solution, right? Fits in this category. Right? So that's kind of the process, right? So you could practice that by pulling exercises out of the book, right? So something that might be helpful is if you go in maybe section 4.2 or 4.3 or even 4.1, and you can pick an odd problem where it has the answer in the back of the book. So just pick any system. So you already know like the answer of the system. So you should be able to identify, if you know the answer, how many solutions exist, right? So then you could use that system and check this, right? You could try this out and make sure that you understand this, right? I would definitely know how to do this, right? This requires you to understand what we're doing, right? All right. Oops. This should be number 2. Oh well. Alright, so next I wanted to look at solving a system with the three methods, right? So some of you said that you had trouble with substitution method or another method, and someone else mentioned that they had trouble with a particular system. I think it was one that had fractions, right? So I'm going to kill a couple birds with one stone here by using the system that someone had trouble with, and I'm going to solve it three ways, all 3 ways, right? So we have three methods that we looked at in the book, right? There are actually other methods also to solve a system of linear equations, but we only looked at 3, excuse me. Right, the first method that you looked at was by graphing. And solving a system by graphing, I think, is helpful just to kind of lay the foundation for what we're doing. So that's a very popular place to start. But hopefully you realize that this is like the least accurate way to do it, right? Because our solution isn't always going to be like whole numbers where it's easily able to tell the exact solution. The next one that you looked at was substitution. And then the next one you looked at was using the addition method. All right, this is also called the elimination method. All right. So the system that I want to look at is the following. So we have x over 2 plus y over 6 equals 1, and x over 3 plus y, or excuse me, this should be minus x over 3 minus y over 9 equals negative 1. Right, so there's my system. Oops. Sorry about that. Just get rid of the numbering. Alright. You know, and something you could do for practice, right? You could look at this this system, put each equation in slope-intercept form, and practice identifying, you know, the number of solutions that this would fit into, right? Which category would this fit into? And when we do things with three variables, there are more than just these three possibilities, right? So the first thing that I would do is we can multiply by the least common denominator of both equations and clear what's called clearing the fractions. So this top one, I have 2 and 6 as denominators, so the least common denominator is 6. So if I multiply both sides by 6, we'll clear the fractions, right? And the bottom one, the least common denominator is 9, right, between 3 and 9. So in doing this, what we'll end up getting is what, 3x plus y equals 6. And then I'll get 3x minus y equals -9. Right? So there's my system. So I'm going to do this all three ways again, but you know, one way sometimes is more convenient than the other. So hopefully, you know, by seeing this, I look at this as, you know, immediately looking at this is plus y, and the second equation is negative y. So the addition method here would be the easiest, right? Because if I just add these together, then my y variable will just cancel out, right? In fact, I can go ahead and, while I'm talking about that, I'll go ahead and just solve this using the addition method, right? So to solve this using addition method, we just want to add my equations together and cancel out one of the variables, right? So we, you know, like I did over here, you know, you're gonna have to multiply the top and the bottom. You know, you might have to multiply the top and the bottom by some constant, and notice that the constant doesn't have to be the same, right? Multiply the top equation by 6 and the bottom equation by 9, right? So now now that when I add these together, the y's cancel out, then I'm broke it down just to be in one variable, right? And that's what all these methods are meant to do, right? Is to go from, so we have two variables which are hard to solve, right? So I need to have a method, a way to break this down to be one variable, right? And then when I know what one variable is, then I can work backwards, right? Do back substitution and find the missing variable, right? So I go from two variables to one variable, and then I go back to two variables, right? That's kind of how it works, right? So now when I add these together, I get 6x. These cancel out, so I get 6x equals, this will be what, -3. So then I divide both sides by 6, and I get x equals -1/2, right? So I found one point, right? One coordinate to my point. So that tells me I'm going to have one solution with this, right? If you actually find an x or a y value, then I know it's going to be one solution. So this is -1/2, so I'm missing the y coordinate, so I can find that by plugging it back into one of the equations, right? So I'll just pick the top one, so we have 3x plus y equals 6. So if I take 3 times -1/2 plus y, I'm going to get 6. So 3 times -1/2 is -3/2 plus y equals 6. Right? And then I add 3/2 to both sides. So that gives me what, y equals 7.5, 7.5, right? So this would be 7.5, right? So there's one way to do this, right? So this was using the addition method. Right, so now let's do this by graphing. Oops. So again, I'm just going to start with the system where we multiply by 6 and 9, right, to make it easier, because we already did that work, right, so no need to replicate. So my system is 3x plus y equals 6, and 3x minus y equals negative 9. Right. So to solve this by graphing, we'll need to graph each line. So probably what I would do, especially since we know the solution already, I know I need to go up by halves each time, right? Right, so be -1, and we'll skip 1, -2. Right, so that way each line is a half. Right, we can do more if we need to. So this x axis, y axis, right? So don't forget when we're graphing a line, right? It's so important to tell your reader what your interval you're going up by, right? So in our case, our reader can easily see that every dash mark is a half, right? So if you don't do that, then your graph can mean multiple different things. So that's very important. Also, you need to identify the x and the y-axis, right? Because that's not always this doesn't necessarily have to be x and this doesn't have to be y, right? We kind of get in the habit of that just by tradition, but we have other other ways to show a coordinate plane, right? So for example, this is often referred to as the right-handed coordinate system, but we also have like the left-handed, right? Where over here is positive x, and this is negative x, and this is y, and this is negative y, right? But also, like in physics, they like to change how the axis is, right? So maybe this is positive y and this is negative y, and then this is the x-axis, right? So we don't want to make any assumptions in math, right? You want to clearly show that what these are and what your values are, right? No guessing. All right, so we need to pick some points in here. So I'm going to graph by finding intercepts, right? So for the first equation, right, if I put 0 in for x, right, that would give me 3 times 0 plus y equals 6. So y would equal 6, right? So 0, 6. Then if I put 0 in for y, that would give me 3x plus 0 equals 6. So 3x equals 6, divide both sides by 3, get x equals 2. Right, so 2, 0. Right, so this is my y-intercept, and this is my x-intercept. Right, so I can graph these. So here's so let me do this in another color, right? So this is the point 2, 0, right? And 0, 6 is here. So then a line connecting those will give me my point, right? So I don't have a digital ruler I can use here. But let me see if I can insert a line. Maybe not. Oh, I can do it here, right? So I'm just gonna pick this line tool. So I'm gonna go from this point to this point here, right? So if you're doing this on the exam, right, you want to make sure that you use a ruler to be as exact as possible, right? So let me try to drag this out. Oops. This isn't quite. All right, there. I think that one's pretty right on, right? So we need to do this for the second line. So I'll just use a different color again. So I'll use red. So I need to make an XY chart, right? To graph, and I'm going to use the technique of finding X and Y intercepts again. So 0 here and 0 here, right? So if I put 0 in for X, I would have 3 times 0 minus Y equals -9, which gives me negative Y equals -9, so Y equals 9, right? So when X is 0, Y is 9. Now I can put 0 in for Y, so I would have 3x minus 0 equals -9, so that gives me 3x equals -9. Divide both sides by 3, I get x equals -3. Right, so then I can plot these points, right? So 0, 9 would be here, and -3, 0 would be here. So then I can grab my line tool again and plot these. Right? So I'll do this in gray. So this point is the solution then, right? Which is -1/2 7.5, right? So we're lucky here that this was easy to tell, right? And again, using a ruler is the way to make sure that you get this exact, right? And you want to be as neat as possible, right? So be careful with that if there's a problem like this on the exam. So then the next technique is using the substitution method. All right. So we want substitution. So still doing the same system, 3x plus y equals 6, and 3x minus y equals -9. So the idea with the substitution method is pick one equation and solve it for one variable, and then we're going to substitute it into the other equation, right? So 3x plus y equals 6, right? For example, I can solve this for y, right? So minus 3x from both sides, and I get y equals -3x plus 6, right? So I took the first equation, solved for y, and then I can plug what equals y, right? This what's in yellow, I substitute that in for this y, right, into the other equation. So with doing that, what I would get is, 3x minus -3x plus 6 equals -9, right? So I need to distribute this negative through, right, because this is minus y. So we would have 3x plus 3x minus 6 equals -9, right? So that leaves me with 6x minus 6 equals -9. So then I can add 6 to both sides, and that gives me excuse me. All right, so that gives me 6x equals -3. So I can divide both sides by 6, and I get x equals -1/2, right, yet again. So then to find the other solution, right, I can just use this. I know that y equals -3 times x, which is -1/2, plus 6. So this gives me 1.5 plus 6, so y is 7.5. Right, so I found the solution, -1/2, 7.5, yet again, right? So we did this all 3 ways and came up with the same solution, right? All right, so then I have a word problem with systems of equations, right, that I just grabbed out of the book. So it says Dave and Sandy are frequent flyers with Delta Airlines. They often fly from Philadelphia to Chicago, a distance of 780 miles, right? So as I'm reading this, I'm a very visual learner, so you might be helpful to just draw a picture, right? So we have Chicago and we have Philly over here. So this distance in between, so flying from Chicago to Philly is 780 miles, right? So it says on one particular trip they fly into the wind. So into the wind, let's see, they fly into the wind. The flight takes 2 hours. 2 hours. And then the return trip, so with the wind behind us, so we're going with the wind. And the time here is 1.5 hours, right? So if the wind speed is the same for each trip, find the speed of the wind and find the speed of the plane in still air, right? Okay, so with this one you have to think a little bit about maybe like very small bit of physics here, right? So when you're flying into the wind, right, you have the plane trying to go in this direction, and then into the wind means the wind is pushing back at you, right? So in essence, if we didn't have any wind, that speed would be faster than with the wind because the wind is slowing us down, right? Hence why it took longer. So the rate here, right, is p minus w, right? So whatever my plane speed would be, but then I have to subtract off the wind speed because it's slowing me down, right? Then when we go with the wind, kind of the opposite happens, right? You have your plane, and then you have your wind coming behind you, so it makes it easier to go, right? Makes you go faster. So your speed is actually p plus w, right? So now we can make some equations with this, right? So into the wind, and I'm going to use distance equals rate times time, right? So when I go into the wind, my distance is 780 miles, right? Because that's the same both there and back, right? And my rate is p minus w, and my time was 2 hours, right? So we'll just say times 2. And then when we go with the wind, my distance is still 780. My rate is p plus w, and my time is 1.5, right? So this is my system, right? And something important when we're doing with word problems with solutions is that your number of variables, right? You need your number of variables has to be less than or equal to the number of equations that you come up with, right? So in other words, another way to say this is if I have 2 variables, I have to have a minimum of 2 equations, right? So if I have 10 variables, I must have a minimum of 10 equations in my system, right? Or else I can't solve, right? So the number of variables tells us how many equations we need to come up with, right? So in this case, I only have two variables, right? I have p, which is my plane speed in still air, and w, which is my wind speed, right? So these are what my variables represent, right? And again, this step is very important also, right? Identifying what my variables mean. All right, so we need to solve this system. So first thing I might do is distribute the 2 through. So we'd have 780 equals, actually we could even do this a little easier. So if I take this first equation, what I can do is divide both sides by 2, right? So this will make that 1, right? So we have just p minus w. And then on this side, right, 780 divided by 2 is what, 390? So then I can do the same thing with the next one, right? Divide both sides by 1.5, right? Alright, so if I take 780 divided by 1.5, I get 520. Right, 520. And then this would be p plus w. Alright, so what I did here is divide both sides by 1.5. Right, we divided both sides here by 2. So this is simply just 390. We can get rid of the parentheses if you wish. Right. So then you'll see what method seems very natural here is the addition method, because when I add these, my w's will cancel, right? So what I would get is 2p equals, right, so this would be 910, right? So we get 910 equals 2p. And if I divide both sides by 2, I get p equals, 455. Right? So then to find w, right, I just pick one of these equations. So like I know 520 equals p plus w. So then we'd have 520 equals, so p we found to be 455 plus w. So if I subtract 455 from both sides, I get w equals 65. Right? So I found p, I found w, right? Good. Right, so I mean, at least for me, I think the most helpful thing with word problems is just reading it slow to understand it, right, and rereading it if need be, and then try and draw a picture, some type of diagram. That's really helpful for me if you're a visual learner like I am, and then trying to solve, right? So you shouldn't just jump in there and just try to do it without thinking about the problem first and kind of coming up with a game plan, right? And understanding what each part means. Right. Alright, so then now I wanted to solve a system with 3 variables. Oops, excuse me. So I picked one out. So I have x plus y plus z equals 8. 2x minus y minus z equals 10, and then we have x minus 2y minus 3z equals 22. Alright, so here's my system. Oops, too far. Alright, so the first thing that I like to do is number my equations, right? So I'll let this first one be equation 1, equation 2, and then equation 3, right? It just makes it easier to be able to talk about them, right? So basically kind of the game plan, what we need to do is we need to go from 3 variables down to 2, and then work our way down to 1, right? And then once I know what one variable is, I just work my way backwards, right? I work back and find 2, and then we'll work back and find 3, and then we're done, right? It's kind of the game plan So personally, I think the addition method is a lot easier with 3 variables, right? So I highly suggest using the addition method. But if you like to use the substitution method, that is in the book, and that's completely fine as well, right? So what I want to do is I want to pick 2 of my 3 equations and cancel out 1 variable, right? So I'm trying to construct a system with 2 variables. So an easy one, might be using maybe equation 2 or equation 1 plus equation 2. And what will happen is we'll cancel out y. And actually we'll also cancel out z, right? But that's just a coincidence in this case, right? So if I add these together, what I'm left with is 3x. Here those cancel, we get 18, right? So if I divide both sides by 3, I get x equals 6, right? So actually, I already know my x value of 6, right, for this, right? So then I need to pick 2 other equations, 2 different equations, and solve the system, right? So I picked on 1 and 2, so I didn't pick on 3 yet, so I have to use 3. So I would probably use 1 and 3, right? And I want to cancel out the same variable. So if I take 2 times equation 1 plus equation 3, then that will cancel out y, right? So 2 times equation 1 would be 2x plus 2y plus 2z equals 16, right? So just multiply everything times 2. And then add equation 3 to this. We have x minus 2y minus 3z equals 22. Right, so add these up. That goes away as planned. I get 3x minus z equals 38. Right? So actually, I like to number these. So this one we'll call equation 4, and this one we'll call equation 5, right? So then you make like this new system with equation 4 and 5. Right? So this is at this step, right? I went from 3 variables down to 2, right? So I only have x and z in the system, right? So this, substitution makes easy here because I already know x equals 6. So if I substitute this in for here, I can find z. So I'd have 3 times 6 minus z equals 38. So I get 18 minus z equals 38. So if I subtract 18 from both sides, I get negative z equals 20. So z equals minus 20. Right? So z is minus 20. So then now I just need to find y here, right? So we can find that by plugging into one of my equations. So I'll pick on this first one here. So I know that x plus y plus z equals 8. And I already know that x equals 6 and z equals negative 20. Right? So if I plug these in, I can solve for y. So I'd have 6 plus y plus minus 20 equals 8. So 6 minus 20 is what? Minus 14. So if I add 14 to both sides, I get y equals 22. Right? So there, that's my third coordinate. So 20, 22. Right? All right. So for this level of a class, I'm only going to give you problems where there's only one solution possible with from a three variable system, right? So there are other options there, and I think it's important to be aware of those. But in terms of if a problem like this were to show up on the midterm or the final exam, you would only be given a case that has one solution as like this problem. All right. All right, so it's like 45 minutes. All right, so let's move on. Chapter 5, and hopefully, hopefully this won't take too much longer. So chapter 5 concepts, right? We're looking at polynomials and exponents, scientific notation, right? So these are some problems that I thought looked good to do from the questions suggested by your peers. So like here, suppose you're simplifying each expression to whether you add the exponents, subtract the exponents, or multiply the exponents, divide the exponents, or none of these, right? So I thought this was a good problem because I think a lot of people like struggle with the exponent rules and whatnot. And there's a really nice summary of the exponent rules in the chapter. I think it's in chapter 5. So I think it's right. It's in chapter or section 5.5, I believe. There's a nice summary, a summary of exponent rules that puts all the rules on one page, right? So I that's helpful to look at. Right, so with the first one, we have a power to a power, right? So you have to remember that this looks like this, right? If I have a to the m raised to the nth power, right, the rule is that I multiply these, right? So here I would multiply, right? The next one, this looks like the rule if I have a to the m over a to the n, and we subtract, right? So we would subtract here, right? Part z, we have z to the 16 plus z to the 8. This would be none of these, right? When we're adding things with different exponents, these are just unlike terms, right? So there's nothing we can do here, right? So then part D, I'm multiplying, right? So this looks like, if I have a to the m times a to the n, where we add the exponents together, right? So here we would add, right? So you just want to be comfortable with those rules and how to use them, right? And also when not to use them, like in this case, we would do none of those, right? So then another question someone had asked about was basically how to solve this problem, number 97, right? So we're trying to find the shaded area in this figure. So to find the shaded area, I would need to take the large area minus the small area, right? Where this is the small area, it's the whole, right? So my large area is, so these are both squares, right? So this would be x squared minus 1, the meters here as well. So I would take x squared minus 1 times x squared minus 1, right? And this would be in meters. And then to find the small area, you would get x times x meters, right? Because inside of here, this is x, right? So to define this, so to find the shaded area, we're going to take x squared minus 1 times x squared minus 1 minus x squared, right? So this would give me what, x to the 4th, right? So multiply those, and then take x squared minus 1, so minus x squared, and then minus 1 times x squared, so minus x squared, and then negative 1 times negative 1 would give me plus 1, and then I have minus x squared. Right? So this will give me what, x to the 4th minus, so 1, 2, 3, x to the squared plus 1. And this is in meters. Right, so this would be the shaded area in terms of x. Right, so it's just a matter of just setting this up and just simplifying. Right. Alright, so the next one, match the expression number 1 and number 2 to the equivalent expressions or expressions in the list, right? So that was a good problem. So let me pull these down. Make some more room. All right. So I would do this one in red, right? So so we have a plus b squared, right? So this is the same thing as a plus b times a plus b, right? My base is a plus b, and I have exponent of 2. So I have two factors of a plus b. So 1 and a go together, right? So those two match, right? And then if you look here and here, right, it looks like maybe these were just multiplied out, right? So let's multiply these out and see what this would equal. So when I multiply this out, I would get a squared plus ab plus ab plus b squared, right? So that gives me a squared plus 2ab plus b squared, right, when I simplify. So part E, right? So I can match part E with number 1, right? So for number 1, we can match part A and part E so far, right? And I know for sure that B, C, and D would also not make sense to go with these, right? Because, in order for things to be equivalent expressions, we have to be able to write them where they're equal the same. And I can't possibly take this trinomial here and rewrite it and make them equal to these, right? So that's all for number 1. So we can look at and see what matches number 2. And you should recognize that this is a difference of squares, right? When I multiply this out, you'll get a squared plus ab minus ab minus b squared, right? So these two middle terms cancel out. So you're left with a squared minus b squared. So this matches with B. So number 2 matches with part B, and that's it, right? So C and D didn't get matched with either of these, right? So then the next one's pretty fun. So we're looking at this quotient rule. We have a to the m over a to the n equals a to the m minus n, and we're asked to explain why a can't be 0, right? Well, if I have a to the m over a to the n, and I'm saying a cannot be equal to 0, the reason why is if a is equal to 0, then that makes this base 0, right? And so we would have 0 to the m over 0 to the n, right? If a were 0. And this would essentially just be 0 over 0, right? Because 0 to any power, as long as the power is not 0, we get 0 back, right? So in other words, 0 squared is 0, 0 cubed is 0, 0 to the 4th is 0, and so on, right? 0 to the negative 5th power is still 0. And we can't divide by 0, right? So that would make this undefined. Right? So that's the important thing here, is my base can't be 0. Right? And the reasoning is we can't divide by 0, right? Because if the base were 0, then the denominator would be 0, and that's undefined, right? All right, so then the next item here is a long division. So I'll work this through. So we have 4x cubed plus 11x squared minus 8x minus 10. Whoops, I said 10, but I wrote 18. Sorry about that. Minus 10. And then I want to divide this by x plus 3. Right? So how I work the long division problems is I only worry about the highest degree term that I have left. So I'm highlighting this in yellow. And what I want to think to myself, x times what will give me 4x cubed, right? And that will be 4x squared, right? So I would write 4x squared here, right, which goes right above 11x squared. And then you're going to take 4x squared times x plus 3, and then we're going to subtract it off, right? So this would give me 4x cubed plus 12x squared. Right, so it's very similar to long division, how you would with just numbers, right? Like if you take 156 divided by, I don't know, 4, right? It's a similar process, right? We think, well, how many times will 4 go into 15, right? Well, you would say, what, 3? You'd write that here, and then you take 4 times 3, which is 12, and you subtract that off, right? And you get 3, and then you bring down 6, right? And you just keep working it through, right? Very similar to what we're doing, right? We just have terms instead. Right, so what I need to do is I need to subtract off this 4x cubed plus 12x squared, right? I need to subtract off the entire thing, right? So I might change this to addition, right, just to make it easier. So these cancel. This gives me what, minus x squared, and then bring down. I just bring down everything, right? So you don't lose track of it, right? So now same thing. I'm focused on simply the highest degree term, right, which I'm highlighting in yellow again. So x, I'm thinking to myself, x times what will give me negative x squared, right? Well, that will be what, minus x. So then I need to take minus x times x plus 3, which gives me negative x squared minus 3x, right? So negative x squared minus 3x. I need to subtract off that entire thing, right? And we'll change it to addition, so those go away. Negative 8x plus 3x is minus 5x, and then I'll bring down the negative 10, right? And then same thing, only worry about the highest degree term. So I'm thinking to myself in my head, x times what will give me negative 5x? Well, it's just negative 5, right? So negative 5 times x plus 3 is negative 5x minus 15. Right, we need to subtract off the whole thing. So we'll change it to addition. That goes away, and we get positive 5, right? And this is called the remainder, right? So you would do plus, and then you do 5 over the divisor, x plus 5, x plus 3, right? And the easy way to remember that is I have 5 things left over, but I still want to divide it by x plus 3, right? So we just put that over x plus 3, and then this would be your answer, your quotient. All right, and the easy way to check it is you can multiply these two things together, right? So if I take this times this, I should get what's in the dividend here, right? The 4x cubed plus 11x squared, so forth, right? All right, well, that's all I have. So this was about an hour video, which is about what I wanted to make it. So good luck continuing studying for your midterm. Don't forget to review the material at the end of every chapter, right? So, look in your textbook at the end of every chapter. There are chapter highlights, chapter review, chapter tests, and so forth, right? I highly, highly recommend looking over all those things in every chapter, right? And another great way to study is think about, like, gosh, what would I hate to see on this exam, right? Because that will give you indication for the material that you struggle with, right? And you'll really study that, right? All right. Well, again, good luck, and don't forget your midterm is due by Friday, end of the day on Friday, right? Good luck.